Hello. Hi everyone. Welcome to week 26.2. This is or 25.2, one of these two. We are going to understand Prometheus and Grafana today. There are three things that are actually left: Prometheus, Grafana, and Loki. If you understand all three of these, you can get almost feature complete with New Relic, the thing that we had discussed yesterday. Yesterday we discussed how do you use New Relic to do monitoring, which is a paid service, very big company, and can get expensive over time. Today we'll understand the open source alternatives, specifically Prometheus and Grafana, which are the popular ones to do monitoring. Before we get into monitoring though, let me do a quick revision of what was done yesterday. I'm not diving too deep into it. The video is on the dashboards, but would urge you to, understand high level in the next 2 minutes. If not, if you weren't in yesterday's class and you don't understand this, then just skip this one and, go to yesterday's video, first look at it and then come here. In the last live, we understood what is monitoring. High level, what is monitoring? Monitoring is when you have a dashboard like this, which has your CPU usage, let's say, your storage, that the amount of space you've filled on your machine, the logs from your specific Node.js process, the amount of error logs that happened, and they let you put alerts on top of these metrics. So what is monitoring? Monitoring is grabbing all of these metrics on a website like this. Yesterday, we created this dashboard, if you remember. Where you could see the stats of my EC2 machine. Now that machine is down right now, which is why you don't see anything. But if I change this interval to 24 hours, you will see a bunch of stats we did in yesterday's class. We checked the CPU usage, it spiked over here a bit, storage, a bunch of logs. We also tried to, one second. Never mind. We also tried to get all the logs and look at them over here. What is the benefit of this? The benefit is you can monitor your systems. You have a dashboard where you can clearly come and see. Now that machine of mine is dead. If there is a bug in my website, how will I debug it? Since the machine is dead, as you can see, there is no logs for the last, 10-11 hours. The answer is because I stopped the machine yesterday. How will I debug things over there? Since the machine is gone, all the logs are gone. I can debug it by going through all the logs that I've stored somewhere. That is what monitoring lets you do. That's the first thing you do with it. What's the second thing? You set up alerts. You say, okay, bhai, if my storage is going above 80%, send me an email so I can clean up my machine, or I can make my machine bigger. And similarly, if the CPU percentage is going above 80%, then send me an email. I need to figure out what's up. This is what monitoring systems let you do. You don't use them for a long time, but as your company becomes bigger, you want you're able to monitor systems and get alerted rather than someone calling you and telling you, hey, this specific issue is being caused, please look into it. So that is what monitoring lets you do. But what is the problem with a service like Datadog, New Relic? They're paid, can never be self-hosted. They're not open source. These guys own your data. You don't own your own data. So, if there is a breach, you lose your data, doesn't really happen. This isn't really a good point. Only good point here is that it's paid and it's very expensive. You have a lot of dependency on them very quickly. And when that happens is, when it's very hard to move out of them, but you need them and hence you have to pay them a lot of money. So hence there are open source alternatives like these. Now you should pick and choose which you want to do. If you're early, if money doesn't matter to you, you should go with something like this only. Easier to get off the ground. What we are learning today though is number one, open source. And since it is open source, there are a lot of tools that are built on top of these open source libraries. For example, hello. Yes. हाँ सर उनको ही कॉल कर लो. आप केट पे दे दो अभी, मैं तो बिजी हूँ, मैं कॉल नहीं ले पाऊंगा, आप केट पे दे दो अभी के लिए. Alright guys, sorry about that. What I was saying was, you'll see today. Oh, there you go. What I was saying was, you will see today how hard it is to, number one, deploy these. A lot of them are not horizontally scalable. You can't deploy them in a distributed fashion. So, it is a pain to maintain these. So pick and choose whether or not you want to do it. But if you do it, by the end of today's class, you will have dashboards that look like this. Let's try to gauge where we're trying to go. Let's try to gauge what we'll be able to self-host today. As you can see, this looks very similar to New Relic. You can come over here, open a dashboard, and see a bunch of charts that you have created, which I just did a while back. But all of this is self-hosted. It is hosted on grafana.100xdevs.com. And if I have the credentials, I can look at it myself. This is my machine. I can look at the code of Grafana, modify it, so on and so forth. If you look at the connections that I can make or the data sources from which I can grab this data, there are so many supported, data sources. What does data sources mean? Wherever this data is being grabbed from, wherever these metrics are being grabbed from. So that is why you might want to use an open source tool. The second thing you will learn/build by the end of the class would be a very ugly page like this. This ugly page has all of my stats from which these charts were made. These charts were made from this very ugly page. If you try to understand this page, let me zoom in a bit. It's basically saying, yeah, this website, week25.100xdevs.com, the total number of HTTP requests on /v2/_catalog was 1. Total number of requests on /about was 1, so on and so forth. So it's a very long text file which has all of my data, and this is where your charts are finally created from. That's the second thing we'll be building. This is just the metrics endpoint. Other than that, this is a normal user application. If you go to the /user endpoint, you will see it returns you some data. But the metrics endpoint here is, a very long file which has a bunch of your data. We'll see how this is eventually used. Lastly, we'll build something like this, a UI for Prometheus. There are two big things to learn, right? There is Grafana and there is Prometheus. Prom.100xdevs.com is the Prometheus UI. Grafana.100xdevs.com is the Grafana UI. So that's what we'll be building today. Let's understand these step by step. To begin with, just Prometheus. Prometheus is great independently as well. Grafana lets you do a bunch of visualizations with it that even Prometheus lets you do the same, but Grafana lets you do it a little bit better with a lot of data sources. But before we reach Grafana, let's focus on Prometheus. What is Prometheus? It's an open source library. But what does this library let you do? It lets you monitor your system. Prometheus is a time series database, and it can monitor your processes, hosts. It can actually monitor your databases. Whatever data you have, it can monitor that. If you want to monitor the number of orders you are getting every day for your e-commerce website, it can do that. Whatever numerical values you want to graph out ever, Prometheus will let you store them somewhere and eventually create graphs out of them. But its architecture is a little weird. So here we'll have to spend at least 5 minutes to understand how Prometheus works. Unfortunately, this is very different from how New Relic works. On New Relic, you don't even care where the data is going. It's going somewhere, I will query it. But here, the way Prometheus works is, it's a very weird sort of an architecture. So let's understand this architecture. If this is your Linux machine, ignore everything else here. If this is your Linux machine where you're running a Node.js application, let's say, this is a Node.js application, ignore everything else. This application will expose a /metrics endpoint, or could be anything else, doesn't matter. The point is, it needs to expose an endpoint where it's dumping all of its stats. If you remember, a while back I showed you week25.100xdevs.com, which has a /metrics endpoint where something is being dumped. Very hard to read and understand what it is, but some data is going over there. That is the first thing you have to do if you ever want to monitor a process. That process needs to export its stats in a certain way. That is something I've done for a Node.js application, but you can do the same thing for a Golang application. You can do the same thing for a Rust application. All of these have libraries that let you export a page that looks like this. Once you've done that is when you can start Prometheus, and Prometheus will begin to pull stats from it. I repeat, when you start Prometheus and give it an endpoint, KR, you are supposed to monitor this endpoint. This is where all the stats are going. It will start to pull data from there. Hakiyat, So it's Prometheus that is asking for data at a certain interval and getting it back? Yes. The Node.js process isn't pushing data. The Node.js process is simply exposing an endpoint, and whenever Prometheus wants, it'll ask for, okay, what is the current stats tell me? What is the current metrics tell me? So what is happening is every 15-20 seconds, my Prometheus that is running somewhere, this library, this time series database is checking the Node.js process, is hitting this endpoint and getting back the total number of requests on, let's say, the slash user endpoint is 2. There are 2 people who have visited the slash user endpoint until now. After 15 seconds, it will repoll it and it will see, let me visit this a few more times. After 50 seconds, it will repoll it and it will understand that now there have been 7 requests, or specifically if you look at the get requests that returned 200, now there are 2 requests that have gone to the slash users endpoint. So it's polling and maintaining a database here. Last time I checked, there were 2 requests. Now I checked, there are 4 requests. So this number keeps on going up and up, and your Prometheus database keeps on polling and understanding. Pehle 2 tha, it was 2 before, now it is 4, which means there's been a spike of 2, and then there's been a spike of 4, so on and so forth. It'll keep on maintaining this data by polling every process you give it. Right now I've given it only a Node.js process, but if I give it a Golang process, it'll take its data and store it here. That's how Prometheus works for processes. But you can also export all of your machine stats. If you want to export your CPU usage, incoming bandwidth, the things that we did yesterday for a host, you can export those as well. They provide you, there is an open source library called Node Exporter, which the Prometheus folks have only created. You start this binary, it will create an endpoint where it will start to export all of your node stats. What does node here mean? It means your machine. So this is your machine stats. Node here does not mean Node.js. Node here means machine. So it starts to export your machine stats. Similarly, it, on some endpoint, let's say this is on an EC2 machine, then EC2-22, on some such port and endpoint, it will start to export data that looks almost like this, but it's not HTTP request total, it's CPU usage total, or it's total space filled, or it's CPU idle time, things like these. So if you start this binary on any machine, that will also start to export the stats of that machine. You can pull those here as well. The key thing is it works on a pull architecture for most use cases. Sometimes you have to push as well. For example, if you have a very short-lived job, if there is a job that starts, runs for 10 seconds and stops, then it might, 10 seconds isn't enough of an interval for Prometheus. Prometheus doesn't keep scraping. It scrapes once every 20 seconds, once every 30 seconds. There is an interval you can set. But if there is a short-lived job that starts and then immediately stops, and it needs to push some metrics, then it can also use something called as a push gateway to push these metrics over to Prometheus. Usually you don't use this. Rarely do you have short-running jobs. But sometimes, if service discovery is hard, what is service discovery? Let's say you have an auto scaling group where you're starting machines, stopping them very quickly. Then also you will see sometimes you force pushing to Prometheus, but by default, Prometheus was built to be a pull-based system, which means you expose your metrics. I will take them from time to time. I will maintain your graph of how things have changed as time goes by. That's how Prometheus scrapes normal services, node stats of this Linux machine, gets it from short-lived jobs. It also has very nice service discovery for a Kubernetes cluster. If you have a Kubernetes cluster, problem remains the same. Pods come up and down very quickly. You auto scale very fast. And here also, you can very easily connect your Prometheus process to a Kubernetes cluster, and it will be able to discover your pods and hit the right set of endpoints to get back the metrics. So what is Prometheus supposed to do? It is supposed to poll a bunch of stats and store them on its side. That is what Prometheus does. And it provides you with a very nice UI where you can visualize them. It's able to gather all the stats. You can visualize these stats on the Prometheus UI. Same thing that you saw over here when we went to prom.100xdevs.com. You can write a simple query. For example, if you remember here, what are the various stats we see? It's total requests or HTTP requests total. So I can run HTTP requests total and see them in a textual format. Ki achha, there have been 325 requests to the /metrics endpoint. Can you guess why there have been so many requests to the /metrics endpoint on this website? Because Prometheus itself is polling it. Since Prometheus is polling the Node.js process every 15 seconds, the amount of requests that have gone to the /metrics endpoint, they were 288 the last time I refreshed. Now if I refreshed, they've gone up to 330. So it keeps on polling it. The UI lets you visualize them. It also lets you create graphs out of them. For example, it lets us see the total number of requests that have happened on the /metrics endpoint is a straight line. The total number of requests that have happened, let's say, on the .env route is just 1, so on and so forth. We'll later see, Prometheus is very notorious in one thing. It always gives you cumulative stats. It is telling you total number of requests. It is not telling you requests per second. If you look at it here, it's not like if I refresh, this starts from 0. It's not like if Prometheus polled this specific endpoint, it starts back from 0. It starts again from 330. And next time it polls, it will reach some 340, so on and so forth. So it's always cumulative. So it's a little hard to convert these straight graphs into time series graphs. Number of requests at this time were 2 and then 5 and then 7 and so on and so forth. Basically, you need to get the slope of this graph to be able to get how many requests are happening per second, but we'll get there when we get there. That's a brief about the architecture of Prometheus. To quickly recap, Prometheus, only Prometheus, no Grafana right now, is a process that you start. It runs on a single machine. It is not distributed in nature. You cannot horizontally scale Prometheus, unfortunately. People have tried, there have been weird experiments, but Prometheus by default is not supposed to run on multiple machines. If you want to scale it, you unfortunately have to just keep increasing the space on the same machine. There's no way to do remote storage, things like these. It's a single node process. It runs on a single node. If you do want to scale it, a lot of times you start multiple Prometheus services and you shard your processes. The Golang metrics will go to my Prometheus server 1. My node metrics will go to Prometheus server 2, so on and so forth. What is it supposed to do? You give it a bunch of services to discover. For example, your node process, your Golang process, your Kubernetes cluster. It will keep hitting its endpoints. It will start to store the data here in a time series format. As time went by, how many requests were being hit? You are giving it this information on this metrics endpoint, and it is scraping it and storing it with it. Finally, it gives you a UI like this where you can then eventually check what were the number of requests as time went by. So that's how Prometheus works. Is that clear? If you understand this, then smooth ride from here. We just have to build all of this. Can we do a quick poll on is this clear? %90 is great. Oh, fluctuating. 86% is good. Let's proceed a bit. As we write some code, we'll understand this better. This is the official definition. Prometheus is an open source system for monitoring and alerting, yada yada. These are the properties of Prometheus that I've discussed a bit. Multi-dimensional data model with time series data identified by metric name and key value pairs. What does this line mean? It means it lets you store not just a metric that you're storing, the name of the metric, for example, total number of requests, but also lets you shove some key value pairs in there. Total number of requests for the get method on the user route that returned a status code of 304 are over here. Total number of requests for the get endpoint on the user route that returned a status code of 200 are 4. So you can, for the same endpoint, you can have different metrics by changing the key value pairs. This is for the ones that have status code of 200. This is for the ones that have the status code of 304. That's what multi-dimensional means. You can eventually search also. I want to search only based on, where the method is get. And it'll just give you all the, however you query this, It'll give you the response to all the get queries, and how the number of metrics with get, you get the idea. The number of requests for all the get requests. If I make this post, then it will show me the number of requests for the post request. There are no post requests that was sent, there only get. The number of requests that have a status code of, let's say, 304 or 200, not a string, 200. We'll figure it out. Missing something obvious. Status underscore code. Status underscore code of 200. And it'll show me, okay, only the slash metrics endpoint and the slash user endpoint were returning status codes 200. So that's what multi-dimensional means. What's the benefit of making it multi-dimensional? Okay, you can search not just the total number of requests, but also the requests that have a status code of 200. What's the second point? PromQL is a flexible query language to leverage this dimensionality. That's exactly what we are doing here. Okay, we are writing a query in this specific language called PromQL, where you can leverage the dimensionality and search narrowly. Okay, how many requests were 200? What you really would be interested in, okay, how many requests were returning a 500? How many requests crashed the server? And these are the queries that you will be eventually interested in. No reliance on distributed storage. I don't know if this is a pro or a con, but it is a single server node that are autonomous. You don't have distributed, you can't scale this horizontally basically. Time series collection happens via a pull model. As I said, it pulls from time to time, but if you want, you can also push via a bunch of gateways. One that these guys have created is the push gateway. Targets are discovered via service discovery or static configuration. You can either statically say, okay, these are my machines, some server.100xdev.com/metrics, or you can do service discovery, especially if you have, auto scaling groups or a Kubernetes cluster. And lastly, multiple modes of graphing and dashboarding support. You can create various sorts of dashboards, both in Prometheus UI as well, or, other tools like Grafana let you create charts on top. So that's a brief of Prometheus. Now let's write some code. You guys understand there is a metrics endpoint we need to expose now, and then we need to start Prometheus, and we need to, quickly see this locally on my machine. A UI like this, where I have an Express application running, people are hitting it, and I can query to see some stats like, how many 200 status code requests happen since the beginning of the application. Let's try to code all of this locally. We're doing it for Node.js, but similar libraries you'll find for Golang, so on and so forth. So let's build this thing right here. Let's build a Node.js application where we'll have a bunch of routes, and then we'll have a /metrics endpoint that can be hit by Prometheus. Steps are fairly straightforward. All the code is actually here on week 25 or 26. Week 26 prom. So you can go over here. Akash, please post it in chat. You can go over here and clone the repository, or if you want to code along, feel free to. We'll slowly build up what we're trying to build eventually. If you feel like this is too slow, for a few people who might already know or have interest in JavaScript already, or / have already built Express applications in the past, this is what we're doing today. Nothing here is too difficult if I'm being honest. So, if you think the class is going too slow, feel free to, go back to the recordings. Or we can do that's fine. Let's code slowly and go from there. First thing we have to do is initialize a TypeScript project. So if you want to follow along, create an empty TypeScript project. Let me pull this on the left. Let me open Visual Studio Code on the right, and let me create a fresh folder called week 26 live, and open this in Visual Studio Code. Once I do, let me initialize a empty TypeScript project, npm init-y, npx tsc-init. And then let me do the standard things we do again and again. Change the root dir to /source. Change the out dir to /dist. Once we've done that, let's install all the dependencies. Initially, There'll of course be express and at types slash express. If you're creating a simple express application, let's just create a simple express application, not worry about Prometheus before, the next few minutes. I've installed the two dependencies, and then I can create a source slash index.ts file where I'll be writing all of the code. What code will I be writing? Simple express application. Import express from express, const app equal to express, app.get slash user, let's say. And then maybe if needed a post endpoint as well. That's it. App.listen 3000. That's how you create a simple express application. The question is, how do you start to monitor the time it takes for a request to come and go? Spoiler alert, I'm almost 99% sure there is some library in Express that might be called, I don't know, Prom Express, that gives you all of these metrics out of the box, that just hooks up to the app object and gives you all of these metrics. We'll be writing all of it from scratch, but you don't have to. Express most probably has a library that you can just do a app.use express prom or whatever that library is called, and it will automatically start to export the necessary things for an express application. What are the necessary things in an express application? How much time does it take for a request to succeed? How many total requests are being sent? So on and so forth. There might be a library that does this automatically. We'll be writing it from scratch. How can I start to monitor all of my endpoints? How much time did it take for them to happen? The answer is you can write some code here. Let's say, this also creates a user, let user equal to something, name Harkirat age 20, and then does some expensive DB operation. Then lastly returns this to the user. So there might be a few things happening here. How can you measure the time that it took for all of this logic to run? You can add a start time here. Okay, const start time equal to date.now. You can add an end time here. Okay, const end time equal to date.now. And you can do something like this. It took whatever, end time minus start time milliseconds. So you can do this. You can, in every endpoint of yours, have the start time at the beginning, have the end time at the end, and log it at the end of the file. Or you can create a middleware. You can create a middleware, let's call it simply middleware right now, which does what? It first calculates a start time, then waits for the next function to run, and then calculates the end time and logs it. This is not correct completely. I'll explain very soon why. But theoretically, this looks right. Okay, I will first calculate a start time, then next will get called. What does next do? It takes you to the actual route, which will do its thing, store things in a database, return to the user, and then control reaches here, you get the end time and you log it on the screen. If I do a app.use middleware, that will begin to happen. Start time will log here, next function will get called. Whenever this succeeds, control will reach here, and then end time minus start time will get logged. This is not completely correct, because if this is an async function, then we won't be awaiting on next. And if there is a DB call here, while the database call is happening, control will reach here and end time will get logged. So you can't really do exactly this. Let's do this for now. Then we look at the right approach as well. If we just do this much, and if we ignore the type errors for now, what have I done? I've defined my endpoints and I've said app.use this middleware. What does the middleware do? It first calculates the current time, calls next, which will actually call the route, which will do its thing, and then calculates the end time and then logs it on the screen. We're not even sending it to Prometheus right now. Let's see if this works. tsc-b to build it. Of course, it will give me an error. So I'm going to ts ignore it for now. We'll fix this very soon. And then node dist/index.js. If I try to hit any endpoint now, let's say I try to hit the /user endpoint, I get back the right thing. And also in the console, it logs, it took 10 milliseconds, 2 milliseconds, so on and so forth, keeps going up and down. So we've sort of implemented what we wanted. We have something that's printing metrics, but we don't want to print metrics. We want to expose them to Prometheus. Let's do that next. Let's first fix this as well. As I said, this won't work for an asynchronous function. And then we'll also introduce how to expose this to Prometheus. Let's go back to the slides. Code looked very similar. We have a middleware that does whatever it's supposed to do, app.use middleware, and if you run it, you see things get logged on the screen. Let's add Prometheus to this. Let's see how can you create the endpoint that exposes data in this format. Before that, we need to understand what kind of data Prometheus lets you export. If you saw here, there were various types of things. There is one thing called HTTP requests total, which looks like a counter. What is a counter? Thing that keeps going up again and again. So HTTP requests total is probably the total number of requests that happens, which probably lies in the very first category here. The first type of metric you can store is a counter, which is something that keeps on incrementing as time goes by. What is a good example of this? Number of HTTP requests that are happening. So what are all of these metrics you see over here? They're all counters. They're going up by a certain number. They never go down. A counter only goes up. Second type is a gauge. What is a gauge? It can go up, it can go down. So you can increment it, you can also decrement it. What is a good example of this? Measuring the current memory usage. Memory usage can go up, it can also go down. So if we had a gauge here, we do not. No, we do actually. Active requests is a gauge. The code is incorrect, which is why it's saying 5 over here. Ideally, the number of active requests should only be 1. What does active request mean? A request that's currently, not yet resolved. If there is someone else on the internet who's hitting this, who hasn't gotten back their response, they will lie in the active requests section. Another good example might be the number of WebSocket connections you have. The number of WebSocket connections your server has. Gauge is a good place to put it because that number can go up, that number can also go down. And lastly, the most difficult one to understand is histograms. If you have something, a histogram samples an observation and counts them in configurable buckets. Now there are two new things we have to learn here. Observation and buckets. Let's first understand these two. We'll get to histograms soon enough. But just to give you a brief, the thing that you see here are histograms. What does it say? It says that the slash metrics endpoint took less than 0.1 milliseconds for 18 requests. The slash metrics endpoint took less than 5 milliseconds for 554 or 554 requests. And then again, the slash metrics endpoint took less than 15 milliseconds for 554 requests, so on and so forth. All of these that you see here are various buckets. It took less than 0.1 milliseconds for 18 requests, but less than 5 milliseconds for 554, so on and so forth. Harkirat, why is this data being stored like this? Why can't I store? Why do I need histograms? Why can't I store one request took 30 milliseconds, second request took 40 milliseconds, so on and so forth? The answer is you can't make this page very big. You can't have, this isn't your database. You can't have million rows over here where with million records of slash metrics endpoint, there was a request for 50 milliseconds, then there was another request for 100 milliseconds, so on and so forth. So you limit it to some buckets. I eventually don't want to know how many people got 30 milliseconds of latency, but I just want to know in some buckets how many of my people are seeing very good response times, how many of them are seeing slightly bad response times, how many of them are seeing very bad response times. So for that, you create these buckets and only store that much data. So even if 1 million users hit the slash metrics endpoint, there are like some 100,000 users who are here, and then maybe 200,000 that were here, and then 500,000 that were here, so on and so forth. So that's what buckets mean. And one weird thing about buckets is they are cumulative, which means there are 18 people that took less than 0.1 milliseconds, but there are 554 minus 18 people that took between this and this. And then there are 554 minus 554, which means 0 people that took between 15 and 5, which basically means for most people, the latency is between 0.1 and 5. So that's why these are all 554, because these contain everything on top plus the people who joined right now. We'll discuss this again when we reach histograms. Let's first focus on counters and gauges and how can you add them to your application. The first thing we'll be adding is a counter. Very simple. Get back from histograms, keep things simple. Let me do a quick poll. How's the pace, guys? Are we good to go? Either way we will go, but just to understand. Okay, not great. Let's take a small breather, guys. 79% isn't great. What do we need? Do we need a quick recap or something else? Let's open chat. Let's take a small breather for 5 minutes. Small 5-minute, call it a break, call it a breather. Recap. Histograms recap. We'll be getting to histograms eventually, but let me quickly recap the types of metrics you store one more time without even implementing them. Counters, if you look at this, even though this is a very ugly thing to look at, just focus on one line. This line right here. Okay, the slash metrics endpoint that returned a status code of 200 was hit 554 times. 554 people got back a 200 status code when they hit the slash metrics endpoint. Similarly, the slash user endpoint, 4 people got back a status code of 200 and 7 people got back a status code of 304. What is 304? 304 means the page was cached. So if you refresh sometimes, you don't get back 200, you get back 304. This is a counter. This number will only go up. The number of requests will only increase with time. That's what a counter is. What is a gauge? A gauge says, okay, what are the active people on the website right now? It could be 100 people who are currently sending requests. It could be 2 people. It could be 10 people. So it could go up and down. And hence a gauge is used when you know a thing can go up as well as down. But the last thing, the most difficult thing, is histograms. Unfortunately, Prometheus, the way it works is, bhai, this is a long file. Here you have to put all of your data. All your metrics need to be here. This cannot be a database. Prometheus eventually is a time series database, sure. But your process in a very small file needs to expose all the metrics. So if you want to calculate, the slash users endpoint, what is the latency here? You will not store, for person 1 it was 1 millisecond, person 2 it was 100 millisecond, person 3 it was 50 millisecond, so on and so forth. You will not have a million rows here. Prometheus will go crazy trying to scrape it, right? With time, this file will become really long. And hence, what the Prometheus guys said was, you can't store the exact value. Sorry. It might be 1 millisecond, 100 millisecond. We don't care. Here are some buckets. These are user defined buckets. You can define them yourself. Here are some buckets. Did the time it take, was it less than 0.1 millisecond? Yes, it was. Okay, the count here is 1. Was the time that it took for this request to get handled less than 5 milliseconds? Yes, it was. Okay. This number goes up by 1 as well, so on and so forth. But then let's say another request comes which took 12 milliseconds. Another request comes that took 12 milliseconds. Will it be able to increase this? No, it won't. It is more than 0.1. Will it be able to increase this? No. Will it be able to increase this? No. Will it be able to increase this? Yes. This is what our histogram buckets would look like after the second request. Let's say the third request is, it took 3 milliseconds. Did this number increase? No, it did not. Did this number increase? Yes. There is now one more request that took less than 5 milliseconds. Did this number increase? Yes. There is now one more request that took less than 3 milliseconds. Did this number increase? Yes. There is now. Unfortunately, they stored it in a cumulative fashion. God knows why they could have totally done this is 1, this is 1, this is 2, this is 1 again. No, it accumulates. So if you ever want to calculate how many of them took less than 0.1 milliseconds, the answer is 1. How many of them took between 0.1 milliseconds to 5 milliseconds? The answer is 1 again. It's 2 minus 1, because one request took 0.5, 2 took less than 5, one of them is already here, and hence, between 0.1 and 5, the answer is 1. How many of them took between 5 and 10? The answer is 0. How many of them took between 50 and 10? The answer is again 3 minus 2, which is 1. So there were total 3 requests only, but these accumulate. Eventually the last one basically has everyone. Last one is usually infinity, which means, you know, a request that was less than infinity, which will be every request. But even if it is 50, you get the idea. It accumulates up like this. That's exactly what's happening here. 18 requests took a really short time, less than 0.1 milliseconds. 554 minus 18 took between this and this, but total number of requests that took less than 5. LE5, less than 5 wali kitni hai? 554. Now 18 of them already lie here, and hence this number would be 554 minus 18. Eventually when we need it. For now though, this is just getting dumped somewhere. But eventually, as if you remember this chart, it kept on going up, right? So this chart is not related to histogram, so let's not discuss the chart. Can we do one more poll now? Can we proceed? We're at 7:45 now. Do we understand histograms? Eventually we will code them. But do we understand how to create them? We'll also eventually understand why we had to break them down into buckets. The answer really is because you don't really care about 80, okay, good to go. You don't really care about how many people have 0.55 milliseconds. You care about buckets. Care how many people were at less than 30 milliseconds. They're having a good experience. How many people are less than 500 milliseconds. They're having a really bad experience. So you can break things down into buckets. You care about those buckets. Why do you need to do that? Because you don't want this file to become really long. You don't want the metrics file to be really long. So every metric will get at max 5 rows, and you know, you'll distribute your data there. All right, let's start to write some code now. Let's expose a simple counter to begin with. We want to expose the number of requests. Let's add logic to count the number of requests, the throughput of our application. If you remember, yesterday we did this in New Relic. Today, we want to now create a row over here that says HTTP total requests with some labels and what is the number of requests that happened here. No cumulative logic here, simple counter. How do you create it? Thankfully, Node.js has a library called Prom Client or Prometheus Client that, you know, lets you expose your custom metrics. As I said, I'm sure there's a library out there that you just hook up with Express and it all automatically exposes the right set of metrics for an HTTP server. Request count, request time, so on and so forth. We are building it from scratch. For us, this is a custom metric. What does custom metric mean? It means we have defined it, Kecha. We want number of requests. We could want twice into number of requests as well. It is in our hands. Let's create our very first custom metric. Let's install Prom Client here. Let's get rid of this middleware. Let's move it to a better file. So this is what our simple Express app looks like right now. No Prometheus at the moment. No metrics either. I've gotten rid of all the logic. Let me create a new folder here called monitoring, inside which I'll expose the very first middleware, call it request count.ts. What is this guy supposed to export? It will export a middleware only. Harkirat, what is this syntax? You can also do export function request count, something like this. Both of them are fine. And what is this supposed to do? It needs to, number one, well, it just needs to increase the counter. It doesn't even do anything complicated. How do you do that? You first have to define a counter. You have to use the prom-client library that we had just used to define a counter. How do you do that? You first import client from prom-client and then you write export. If you want to export it, for now we don't need to. Const request count equal to client dot counter. And what are the arguments you can give? Again, it's the same thing here and here. And method route status underscore code. These are the three labels that we need on our application. What's the type here? Client dot, oh, new client dot counter. There you go. There we go. We have named it request underscore count. This name is what will finally appear here, HTTP requests total. We've given it some help, as in some description of it. This will also appear somewhere here. If you search for help, there'll be a bunch of comments that basically state कि अच्छा this specific counter key, this is the description. You can again use this in the future whenever you're showing things in a UI. And lastly, the most important thing, कि what all labels do we want to divide the data on? As I said, it's multi-dimensional. If you saw here, it did not just count total number of requests. It counted total number of requests with this method on this route with this status code, and then total number of requests on this method on this route with this status code, so on and so forth. So you can add as many dimensions as you want. You can later on aggregate your data. It's not necessary that it will only always give you 615. You can say I want all the get requests. It will add all of them for you. But for now, we have 3 separate labels. You can also make this lesser depending on, your use case, whatever you want. Now, what needs to happen here? Whenever a request comes, what needs to happen? We need to increase this counter by 1. The request count middleware, when the request finishes, does a request counter.inc. Doesn't matter, you can also do it. To keep things simple, you can simply do request counter.increment. Method is this, route is this, and status code is this. The method, if you can log all 3 of these, and you'll realize this represents, the method of the user request, could be get, post, so on and so forth. This is the route / the path, and lastly, this is the this status code you can only get after the request has succeeded, and hence you can't do this. You have to wait. That's why rest.onFinish is something you need to wait for. If you don't wait for the response to come back, you don't know what the status code will be. This will probably be null, and hence you first have to wait for the request to finish. Thankfully, the response object here has an event listener that you can listen on. Anytime the request finishes is when you increment it. If you don't need status code, then this is fine as well. If you want just this much and want to keep things simple, this is fine as well. You simply increment it and call next. What does calling next do? The control actually reaches the route. So this is our final file. If you are following along, feel free to write it. Most of it is in the slides. Here is a more trimmed down version of it. If a request will come, it will first reach this middleware, which will increment our counter and then call next. Harkirat, what does incrementing the counter means? The metrics endpoint will just add a 1 to that specific, method and route. What are we saying? Okay, this method and this route, please add 1 to it because a new request has come. So this will go up from 615 to, let's say, 616. That's the first thing you have to do. I'm going to wait for 20 seconds and then I'll proceed. To quickly recap, we are dealing with counters right now. What are counters? That go up 1 by 1, never go down. How can you define a counter? You can use the prom client library. You can create a new client.counter and you can give it a name, a help, which means, some description along with it. And lastly, a bunch of labels. Okay. This method, route, and status are going to be our dimensions. Then whenever a request comes, we'll hook it into this middleware. Ignore the start time. You don't need this. We are not logging this anymore. We simply say when the request finishes, whenever res.onFinish gets called, we increment the response by the request by 1 on this method, on this route, and then for this status code. For our code, we completely ignore the status code, which is why we don't have to wait for the response to come back or the response object to be resolved, because we don't need the status code. Unfortunately, this status code will be calculated here, right, in the method body, and hence you can't just use it upfront until the response has finished. That is why there is a rest.onFinish here, but this is a simpler version of the same thing. If I save this, TS, ignore this to keep things simple, but if you want types, they're present here in the slides. You can look at the types and where they're imported from. They're all imported from Express. We export this. What is the next thing I have to do? I need to tell the app.use request count, which is coming from here. That's all that you have to do. To start to call request counter.inc, we still haven't done one thing. We haven't done app.get/metrics. What should happen whenever the metrics endpoint is called? We still need to do that, but we've hooked up a middleware which will be called every time any request comes, this will be called and the counter will go up. Let's lastly expose this metrics endpoint, which again, the prom client library gives you a function called client.registers.metrics, which will basically export all the metrics that you can just send back to the end client. You just need to import the client at the top. So import client from prom client, and then anytime a request comes to /metrics, you need to return the content type as well. You can also hard code it to whatever this is. I think this is going to be, I don't know what this is going to be, probably text, plain text, something like that. And then client.register.metrics is the function that gives you all of those metrics, that has access to, there is a request counter, and then you return that to the user. If you run this tsc-b, then node this/index.js, and you try to go to localhost 3000/metrics, you see an error. It says cannot read property of undefined reading path, probably happening in the middleware. Path request.path, I guess. Let's try that one more time. The route needs to be not request.route.path, it simply needs to be request.path. There we go. You can also write this more foolproof logic if you want. Either is fine. I think this depends on the express version you are using, whether or not request.route.path is valid or request.path is valid. Let's try that. Let's go to /metrics. And now, as you can see, it says one request has come to the /metrics endpoint. This is sort of unfortunately vague. You don't ever need to track this. So, you should ideally just ignore increasing the counter if a request has come to /metrics, because this, though, of course, will only be hit by Prometheus, right? No human will be hitting it. You don't have to actually pull this specific or, worry about this specific endpoint. But if I open localhost 3000/user, refresh this a few times and then go here, you will see it says 7 requests to the /user endpoint. Again, converting this into time series data is taken care by someone else. You just have to export your metrics. That's exactly what we're doing here. We're able to export the number of times a certain endpoint was hit. The same thing is happening here for, a more foolproof application where the number of endpoints are much higher. Some bots are running that are trying to, hit this specific, most probably this is a vulnerable endpoint. There's some bot running there that's trying to hit it and, trying to find a vulnerability on the system. But for us, our application has 2 counters right now. Fairly simple application. Are we good to go, guys? Let's do a poll. Do we understand counters? Oh, we don't understand counters. Okay, 80%. Quick 3-minute Q&A we'll do. Also break for people who need it. Chat is open. Any specific question or do I need to recap? What are you using to export metrics in 100x.com/metrics? You mean, so there are no metrics being exported on this website, if that's your question. That website isn't even owned by us. Recap. Okay. Can we add Prometheus to next year's application? You indeed can. You have to write similar code. You just have to make sure it runs on a server. It should be in a server component. Everything else should be exactly the same. To recap counters, if you ever want to calculate the number of requests or, eventually create a graph that looks something like this. Sorry, not this. This here, how many requests are coming to our service? Maybe you want to boast off to your friends. We received 1 million requests in 2023. So you need to keep a track of these, right? How can you track them? The answer is you can expose these endpoints on your specific application, or not expose these stats. And what is the stat that you need right now? Counter only goes up, and hence you need to create a counter. How did we create a counter? Prometheus, thankfully, exposes a client.counter class that you create a new instance of. You give it a name. Whatever name you give here is the name that appears here as well. You give it some help text कि अच्छा भाई this specific request count, this is the description for it, and lastly you give it some label names कि यार method and route are two things that will exist on every route of yours, and then lastly, sorry, every metric of yours. Whenever you are increasing the counter now, when you call request counter dot increase, you tell it कि increase by 1 on this method and on this route, and hence that's exactly what you see on the left. Anytime there is a get request to slash metrics, as I'm refreshing this, there is a get request coming to slash metrics, right? And you can see the number is going up. Okay, more and more people are visiting this. That's how you can keep a track of your total number of requests. And this is a counter because it only goes up. That's what a counter is. Let's go to a gauge next, and then I'm happy to take a pause and breathe for a bit, take a break as well. Let's try to complete. Oh, we actually have to understand, structure the application a little bit better before we reach the gauge. Let's not worry about that. Let's directly go to the gauge, and then I will share maybe a little bit as to why I wanted to structure the application a little bit better. Let's go to the gauge. Let's say you want to track the number of active requests. What is an active request? A request that has currently reached our systems but not been resolved. I repeat, anytime a request comes to app.getUser, when the request is here or here until it has responded back to the user, that is an active request. This is something you usually don't track for HTTP servers. You track it for WebSocket servers. Okay, what are the currently total number of active WebSocket connections I have on this server? That can go up, that can also go down, and hence you use a gauge over there. How can I replace, let's say, we just in the same file here, try to create a gauge now. Rather than creating a request counter, I will create a request gauge, let's say. That's the variable name. And rather than doing a client.counter, I will create a fresh gauge, which again can have the same properties. A name, which could be, what are we trying to gauge again? Number of users. So I'll call it active user gauge. I will call this active underscore users. And then some help, total number of users whose request hasn't yet resolved. And then let's say we do it again on this method and this route. How can you calculate this? When should you increase this? When should you decrease this? The answer is whenever a request comes, control reaches here, you need to increase this. Now there is an active request that is being handled. So over here, you can do a request active user gauge dot increment on this method and this route. And when the thing finally resolves, res.onFinish, whenever this next function gets called, it eventually does its thing, responds back to the user. Whenever that happens is when you decrease it by 1. You want to make sure it goes up when a request is being handled, but as soon as the request handling finishes, you want it to go down as well. That is how a gauge works. Let's see if I replace this. I'm still using it right here. The name isn't the best. It should be called, active user gauge or something, but this is fine. Now if I run this again and try to look at the stats, it says active users is a gauge, method get route metrics. There is one active user here. Unfortunately, this will always remain one when you're hitting the metrics endpoint. You yourself are the active user. But if I go to another, this thing here, another URL here, it will go up by 1. And then, after the request response, it will go down by 1. And hence it says 0 over here and 0 over here. Unfortunately, it will be very hard for you to recreate. I refreshed and immediately I see an active user. But you get the idea. For some small time, this gauge value is actually going up by 1. And then, is eventually going down by 1 as well. You can put some logs here. Or you can, let's add a small set timeout here. We will only decrement this after 10 seconds. That way you can see the request go up, and only after 10 seconds of the request finishing are we decreasing it by 1. Let's say you're measuring the number of people that were active in the last 10 seconds, or the number of requests that were active in the last 10 seconds. then you would defer the decrement by 10 seconds. If I now restart the application, if I now go to /user and refresh metrics again, you can see users has 2. Eventually this will go back to 0. But since I opened user in 2 places and the gauge got incremented but hasn't yet been decremented, after 10 seconds, it goes down to 0 again. So do we understand counters and gauges? I will take a break after this and happy to recap, but let's do a quick poll. Okay, do we understand these 2 slides? One on gauges. This is how you create a middleware where whenever let's just 8%, 75%, 78%. All right. 10-minute break, guys. So we'll take a break until 8:15. Next 10 minutes, let's discuss what's up here. Let me look at Q&A or chat a little bit. Gauge versus counter. Counter will only go up. You cannot decrement a counter. Gauge can go up. Gauge can go down. Why can't there be more than one active requests? There can be 100 active requests. I said it's very hard for you to humanly create them. Okay, I go here, I refresh. By the time I come back and refresh here, that request has become inactive. But of course, in the real world, there will be 100 active requests. Metrics endpoint doesn't show anything for you. Try to debug it. Try going here, go to the metrics endpoint, send your own thing from here. Rest.send. Send your own data from here. Do you see this? If you don't see this also, then maybe try commenting out the app.use. Maybe your middleware has a bug. Maybe you're not calling next. Is Prometheus like Splunk? No idea what Splunk is. A Cisco product. Probably. I don't know. Splunk, Cisco. Can we open chat? Let's keep it open for a while. All right. Please explain route. Okay. So this part right here, as you saw, I just simply wrote rec.route.path. Sorry, yeah, exactly this. This is what I initially wrote. But if you log rec.route, you will see this is undefined. In some older version of Express, this was defined. In a new version of Express, rec.path has your actual, route. And hence, to ensure backward compatibility, some of you might be using the old version of Express. I'm using the new version of Express. And hence, what we say is, if request.route exists, this is called the ternary operator. Maybe you have not heard of, tried this. So you can also do this. Let route equal to null. If rec.route exists, then route is equal to rec.route.path, else route equal to rec.path, and you can simply use route over here. This is just another way to do an if else. It's called the ternary operator. In a single line, you can do all of this if else logic, but what you've written, that's fine as well. All right, this is done. Look at chat one more time. Great question. Is exposing the endpoint safe from a security perspective, or shall it be allowed on an ACL basis? Because always highlighting endpoint, yes, so you will have 100 types of authentication over here. At the very least, you will check if request dot, whatever headers dot secret is not equal to some secret. You will not allow anyone to hit this endpoint. You will have some basic authentication, maybe even more complicated authentication here to make sure this is not exposed to the world. Is Prometheus creating an in-house variable to store data? Can we create a counter class of our own and do this? No. I mean, you can. If you can create your own counter class and then eventually export it like this, the goal is, final thing should look like this. It should follow this. I would assume this is PMP, Prometheus query language syntax. If you can maintain the counter yourself and finally export this file yourself, the shape of which looks like this, then you're good to go. You don't need Prometheus client at all. The thing that the Prometheus client gives you is exporting this in this format, in this specific query language. If you can do that yourself, you can create your own set of counters. You don't have to use the library at all. If this data structure only works for Prometheus, while migrating from Prometheus, Grafana and low-key data Dognia Lake, will we need to structure our application middleware? Yes, you will. I would assume there is a way to convert this into a format that can be understood by other monitoring services, or this language is being understood by a bunch of other monitoring services that came. But yes, if you want to move from here to there or there to here, there is some effort required in how you're exporting data. How do these guys make money when they self-host? Like most open source companies, consulting, helping bigger companies set up. They have their own cloud sometimes. You go through. How does MongoDB make money? MongoDB is also open source, right? There are ways to make money as an open source company. All right, we'll come back to this question. Okay, let me quickly recap what we have done, and then let's defer a few things to an offline video. Let's understand histograms and the final code, starting Prometheus. Queries Prometheus. Let's try to just cover this much. Let's try our best to cover everything before Grafana, and then let me cover Grafana in an offline video. To recap from the beginning, today we thought of learning about a very new stack, not a new stack, but like something we've not learned until now for monitoring. The stack is called the Prometheus and Grafana stack. How does it work? Before we got there, we understood what is monitoring. It lets you create charts like these. That's exactly what we're aiming for today as well. Okay, by the end of the class, we can create, some charts that I already showed you in the beginning of the class on grafana.100xdevs.com. Today, we'll just be focusing on Prometheus. We went through the Prometheus architecture. Okay, if you have an application, be it a Node.js application, a Golang application, or your full machine that wants to export its metrics, things like CPU usage, storage, you need to export it a certain way. You need to export it in a syntax that looks something like this. And once you do that, Prometheus can start to pull them from time to time and maintain a time series database over here. Given this time series database, a Prometheus UI can, poll it and store things here. That is what that is the architecture of Prometheus. Then we discussed, okay, let's create an Express application that starts to export some of these metrics, specifically things like these. Okay, the total requests that have happened on this endpoint with this status code, how many of them are there? Or the total number of active users on the website, the people who have trying to hit the website, haven't yet gotten back a response, whose request is currently stuck on the server in some database call, let's say. We try to cover both of them. We realized this number only goes up. The number of requests will keep on increasing as time goes by, and hence this can be a counter. And similarly, this thing can go up but can also go down as people, if no one's using our application, this will be back to 0. If 100 people come together, your database becomes very slow, then there might be 100 active users on your website. So since this can go up and down, it can decrement as well. This will be a gauge, this will be a counter. How did we create a counter? We use this library called prom-client that lets you create a counter like this. Const request counter equal to new client.counter. You give it some metadata, but most importantly, you give it your dimensions. Okay, I want you to segregate data based on method, route, and status code. And then whenever a request finishes, or in our case, we made a simpler version, even before it finished, we did a request counter.inc, which means increment it by 1. Whenever control reaches here, this event listener will get registered. Next will get called, the endpoint would do its thing, and then control would reach here. The thing would get incremented by 1. Then the most important thing was that we, number one, registered this middleware as well. We did a app.use request count middleware, and then we did an app.get/metrics. If anyone is trying to hit the metrics endpoint, they should get back all the metrics that come from the same client, prom-client. And by the end of this, we saw a page that looks like this. Yeah, the /metrics endpoint was hit with a get request 17 times. The /user endpoint was hit with a get request 6 times, so on and so forth. That is how we created our first metric, which was a counter. The second metric that we had was a gauge. What is a gauge? It lets you increase as well as decrease. That's the only difference. There might be some other difference actually, but the bare minimum difference that you need to know is if something goes up and down, you use a gauge, you cannot use a counter. We created a gauge, we gave it a name, the number of active users that you have. Maybe you don't even need to know them on a route by route basis. Okay, how many people are hitting endpoint A or endpoint B? You can use them globally as well. That's exactly what's done here. This is why, if you look at it, active users has no dimensions. It has none of these. Single active requests, which is the number of requests that are currently active. We created we did it a different way here for better structuring. But if you remember in Visual Studio Code, the way we did it was we defined the gauge. We added labels as well, which feel free to remove. And then we can simply increment the gauge over here. What is over here? Whenever a request comes and this middleware gets called, we increase it by 1. Whenever the request finishes, it triggers this endpoint where we can decrease it by 1. That is how we have created a gauge. Only 2 things we have discussed: creating a counter, creating a gauge. Next thing is a little difficult. We'll probably just do that and call it here. I'll do even Prometheus in an offline video, and I'll probably start from scratch and explain everything. So seems like this is a heavy class. Happy to redo it in an offline video. But let's try to finish histograms a bit. And once we do finish histograms, let's open it up for questions. All right, going to proceed now. But as I said, if you're at a point where you can't understand, there will be an offline video that will start from scratch and cover everything. Let's get into histograms next. As I said, there might be some metrics that you need, that can have infinite values. This can only go up and down. Active user count will go up by 1, go down by 1. Total number of requests will, keep going up, but it will be a single number. But if you want to calculate time, for example, the amount of time it took for a request to be resolved, if I'm going to localhost colon 3000/user, it might take 1 second, might take 0.1 second. Every time it will be different. How do I store this on this page? Do I have a million rows over here for a million requests that came? Or can I somehow create buckets? What is a bucket? Something like this. Here, how many requests took less than 0.1 millisecond? Let's say 10. How many took less than 5 milliseconds? 50. 1 second. 100. Infinite, which means how many requests eventually got resolved, doesn't matter in how much time. 120. I can store data like this as well. I can just have 4 rows in my final thing. Or over here, as you can see, I have 8 rows for the total number of time that it takes for the /metrics endpoint on a GET request that returned a 200 status code. I can have infinite of them, but I just say, I'm worried about the buckets only, because eventually my query will also not worry too much about कि अच्छा 3 था कि 5 था. I don't care if it was 2 milliseconds, 3 milliseconds or 4. I care how many people are doing very good, how many people are doing good, how many people are doing okay, and then how many people are doing really bad when it comes to the latency. So we break them down into buckets. If you break it into 4 buckets, you will see 4 rows over here for every route. If you break it into 10 buckets, you'll see 10. What if I create million buckets here only? Then you're shooting yourself in the foot. That's the thing that we're trying to avoid. Okay, mota, how much do you need? How much is good enough metrics for you to collect? The answer is you find some, good middle ground. And then you store data like this. The only thing to keep in mind is this data is cumulative. What does cumulative mean? It means it adds up. This has 10, which means number of requests that were less than 0.1 milliseconds are 10. There are 10 requests here. But if this is 50, it means 10 are here and 40 are here. The total number of requests here are 50. 10 are here, 40 are here, and 50 lie between 5 milliseconds and a second. That is why this is 100. And then 20 lie over here between 1 second to infinity, which means they took more than 1 second. That's 20 is the total number of requests there. So this data is cumulative and you sort of use it that way. Do we understand this? Can we do a poll? Cumulative data we understand. If you look at the requests here, 19 requests that took less than 0.1 milliseconds. 594 requests, which is, this number minus this number, that took 90% is great. That took this much. And then, basically 0 requests that are between 5 and 15, 0 requests that are between 15 and 50, so on and so forth. Let's understand how can you create a histogram next. How can you export data like this? How do you use this data for a chart is something we'll get to eventually. But let's understand, if you have this data that's very vague in nature, can be 0.1, 0.11, 0.2, how do you create a histogram for it? The answer is, again, it exposes something called as a histogram, but the inputs you need here are not just the name and some helper text along with it and some labels. You also need to define the buckets over here. What are these buckets? These things right here. What are your checkpoints on which you worry about data? Number of people that had less than X, Y, and Z. You have to define those buckets over here. And then you can just, again do an increment, decrement. That part is straightforward. You can't do an increment and decrement. You have to do an observe. We'll get to what that is very soon. Let's bring a histogram into our code base text. In the same middleware, let's replace the gauge with a histogram for the total time it takes for a HTTP request to happen. How do I calculate that? I first need to calculate a start time, which is date.now. And when the response ends, when the request finishes, is when you can calculate an end time, which is also date.now. And then you can do HTTP request milliseconds, whatever, dot observe. You are not increasing or decreasing. You are observing a specific metric with, these inputs. Duration, same thing. With these dimensions, okay, the method was rec.method. The route was rec.route.path or rec.path. And the status code or the code was rest.status code. And the second argument you give it is the total time it took, which is end time versus start time. This will be, 0.1 millisecond, 1 milliseconds, 2 milliseconds based on how much time it takes for this specific next function to, eventually resolve. Database made data goes, fetches happen, everything happens. Then control reaches here. We observe, okay, this time happened. This time could be 0.11, 0.123, or 1000 milliseconds, so on and so forth. If I save this now and try to rerun it and go to the metrics page, it says access was denied because I added a check over here. Let me remove it. And now, right now, you see nothing. If I refresh, you see a bunch of buckets are created. KR 0.1 milliseconds, it took one request, less than that much time. It took 5 requests between 0.1 milliseconds and 5 milliseconds. It took one request between 5 milliseconds and 15 milliseconds. And then, everything else is 7. This is the total duration of, this is the actual total duration. You also store the cumulative duration, 0.1 plus 2 milliseconds plus 4 milliseconds. If you add them up, that adds up to 23. And this is the total number of requests that went out. This becomes useful when you want to find the average. Okay, what is the total average time it took for any request to be handled? But do we understand how to generate metrics? More specifically, a histogram metric. Let's quickly recap it. You use the client.histogram, which is something that the prom client exports. Again, you can do this yourself. Someone asked, can I create this yourself? You can. You can write logic over here that checks, does this lie in the first bucket or the second bucket or the third bucket, and stores it in some sort of a class. And whenever you're exporting, you export your own, better version of this right here. So you can do this yourself as well. But we have done it using the prom client library. And how do you use the prom client library? You create a histogram and you do a histogram.observe. These are the dimensions and this is the net time that it took. If you want to keep things simple, you remove the dimensions. You're like, I just want to find how much time any request takes. It doesn't matter if it's a get or a post or what the status code of it is. So if you do this and rerun the application, if you refresh, you see they're not being divided based on, there's only one thing here, one dimension here, which is the ones that are less than 0.1, the ones that are less than 5, the ones that are less than 15, so on and so forth. The other dimensions went away. Doesn't matter if it's a get request, post request, doesn't matter if it's to slash metrics or if it is to slash user. We are simply calculating the total number of requests or like total time on any request irrespective of the dimension. That's how you create a histogram. Do we understand a histogram? Can we do a poll? Oh, great. So this is great. We're only at 824. 85% is great. So let me cover the next slide as well and, take you guys through. If you have a decentish application, that basically exports a bunch of endpoints. As you can see now, prom.100xfs.com exports a lot of things. How can I start Prometheus? How can I start this thing right here? And start to plot them a little bit. Let me give a little bit brief into it, and then happy to take a pause and breaks. So we have done this until now. We have one service which is exposing a slash metrics endpoint. We now need to actually start Prometheus. Harkiyat, you to use the prom client library. Yes, that is a library that simply lets you export metrics a certain way. It lets you export metrics this way. It does not actually start Prometheus. It does not store your data anywhere. It expects someone to start and ask for the metrics from time to time. We need to now start this thing over here. We need to start Prometheus locally. Can you start it without Docker? Yes, you can. You can install it from source, get the binary, run it. Or you can use our favorite friend Docker. We've used it many times to pull this data, to start Prometheus locally without actually installing it. So feel free to do either. Here is the way to do it in using Docker. You number one have to create a config file called prometheus.yaml, and this will have a bunch of your configurations. This is a really small one. You can put 10 different things here. For example, if you want to alert via emails, you will put your SMTP credentials here. If this specific target has some sort of authentication, you'll put your headers that you need to send along, so on and so forth. Since ours is an open application right now, running on localhost :3000, this prom.yaml is a valid YAML. What will it do? It will every 15 seconds poll localhost :3000 / metrics. It knows that's the default endpoint. You don't have to write it here. If you have changed the endpoint to something else, then you have to add, a bunch of other keys here that explain this is the endpoint to hit. You create this configuration file. That's step one. Let me create that right next to this code. And the second thing you have to do is actually start Prometheus and tell it that this is where the YAML file exists. So if you look at the Docker file, the Docker command, it looks like this. It says Docker run port mapping, because 9090 is where Prometheus finally runs, or prom.100xfs.com. That process starts on 9090 by default. A volume for ./prometheus.yaml to map to /etc/prometheus/prometheus.yaml. We're putting this file over here. Basically, you can make this easier by creating a Docker file and copying over the file there, or you can just create a volume that sort of points to the prometheus.yaml file from inside the container. And then lastly, we're starting this image right here. It won't work yet because in another terminal, I need to start my Node.js application. So now that this is running and we have this as well, let's try to go to localhost :9090. And you will see, I see some sort of a UI. It says Prometheus here. I don't know what to do with it, but is it currently working? I have started this inside Docker, and my localhost :3000 is running outside of Docker. This is not containerized. This is containerized. If you go to status and targets, you will see it says nothing exists on http://localhost :3000/metrics, even though if I go here, something does exist. Can you guess what is wrong here? And why is my Prometheus server not able to visit my main server, my Node.js application? Anyone in chat? Network add karna padega, is right? Yes, you will have to add a network. That is correct. To quickly recap, if you go back to the Docker class, if you start a container and do a localhost colon 3000 inside, this localhost points to the same container. This container does not have anything running. Your Mac machine has something running. Your container can't talk outside your container. Localhost there does not mean Mac machine. It means the same thing. And hence, you can do a few things. You can either containerize the application and add them to a network and make sure they can talk to each other. That's the easiest thing that you can do. That's what I've done here as well. I created a Docker file for my Node.js application from node 20. This is the working directory. Copy over package.json, run npm install, copy the rest of the files, expose port 3000, and then this should be npm or node index.js. So let me copy this and create a Docker file right here. This should be replaced with node dist/index.js. Ideally, there should be an npm run build here as well, or tsc-b here as well. I'm just ignoring that for now. Since we're just copying everything, we'll copy the dist. But yeah, ideally, since this is a TypeScript application, you should do a tsc-b, and only then will you be able to do this. Then we create a Docker compose file. We create Docker compose.yaml, where we have two services. Now, if you've not done Docker compose, this might be a little hard to understand, but we start two services in a single Docker compose file. What does Docker compose mean? It means start multiple services, compose multiple services together. We say this should build using the Docker file in the root folder. What does build dot mean? It means pick this Docker file and build using it. This is the port mapping for our application. This is the networks for our application. We have created a fresh network called monitoring. Why did we have to do that is a question I will leave at the end of the class. Because if you have Docker compose, if you remember from the class, you don't have to create networks. Everything is automatically connected via a default network. But I still created a network here at the bottom, just how we, if you remember in the past, have created volumes, whatever, Prometheus data, let's say. I created a network and I'm attaching both my Node app as well as Prometheus to the same network. How does Prometheus start? It simply starts this image and we have a volume over there so that the current folder, which has prometheus.yaml, gets mapped to /etc/Prometheus. This is not great. This means my full folder I am mapping here. My source code also I am putting here, which we don't need to. We just need to put the prometheus.yaml file. And then this is the port where it starts. The key thing to notice here is these guys, since they are part of the same network, they can talk to each other. But do you remember how services can identify each other inside a Docker network? It was using their names. So I also have to replace in prometheus.yaml localhost with node-app. Harkirat, what does this even mean? Is this a website like google.com that you were able to write node app over here? No. Anything that you see, be it localhost or google.com, effectively is a domain name that points to something. If I do ping google.com, it points to this domain name. If I do ping localhost, it points to this domain name. And similarly, inside that container, if you try to do a ping node-app, it will be able to find the IP of that specific container and talk to it. That is why localhost will not work here, but node app will. Why is it node app? Because that's what we named it here in the Docker container. If there are two things connected to the same Docker network, they can talk to each other using their names. Their name resolves to the IP of the other container. If I run this now, docker-compose up, what does this command do? This command will start both the services. It will start the Node.js application. It will also start the Prometheus application. And I have already said, keep prometheus.yaml. This is where you will find this is your target. This is where you will find the metrics that you're trying to find. If I do Docker compose up, taking a long time. TLS handshake timed out. Is my internet? There we go. All right. It says network has been started, container has been started, container has been started. There is also an error. Port is not available. That is because I had this running in another terminal. Let me turn this off. Let me try this one more time. And now things seems like things are up. If I go to localhost colon 3000 now, I do see everything. If I go to localhost colon 3000 / metrics, I do see the metrics. Seems like they're doing their thing. If I go to localhost colon 9090, I see the Prometheus dashboard. If I go to the status and click on targets, it says this thing is up. Node-app colon 3000 / metrics is up. It is able to discover the node container. I won't be able to. My server pe node-app means nothing. But from inside the container, from inside this Prometheus container, there is another container next to it, and they can talk to each other by using this sort of addressing for that specific container. For the Prometheus container, the Node.js container can be found out at node-app. So that's how our Prometheus is now scraping data from time to time. What was the architecture? We have started this now. We have given it another source. It's pulling metrics from there, and we can now query on top of those metrics. If I go here to Prometheus and write, what are our metrics? HTTP request duration bucket, I can see all of those buckets and how much time was present here. If I go to the graphs, I can also graph out each and every request and how it goes up over time. What we need to do eventually is, add better graphing, not just have cumulative graphing. We don't have anything else here right now, but let's say, total request duration, some HTTP request duration millisecond count. There you go. If I add this specific metric, which we'll dive a little bit deeper into as we go to the offline video. This metric is the total number of requests that have come. And if you see, it keeps on going up. It'll keep going up and right. This is not the rate of the number of requests. This is not the rate at which the requests are going up and down. This is literally the total number of requests, which will always go up. So we will eventually understand how can you, get the rate, or, as you can see now, that there were some requests, then no one was sending requests, then more people are sending requests. How can you convert this, get the slope of it basically, and make dumb graphs like this? And then we will understand about Grafana and how you can make, slightly better graphs that look something like this. By the end of it, we'll try to create these sort of graphs, which are, the number of requests that the user sent per second. As you can see, this is constant. Or here, the number of requests to metrics is constantly going up to the right. But you can also find the metrics requests per second, which will go up and down based on, the number of requests that happen. If you look at this number of requests to metrics per second, it is 0.0667. This number is also 1 divided by 15. So what does that tell you? Okay, 1 divided by 15 is 0.066. And the number of requests per second is also 0.666, which means this endpoint is indeed being polled every 15 seconds. And that is the interval that we had over here in Prometheus.yaml. 15 seconds was the interval. And indeed, in a single request, 1 divided by 15 requests are happening on the metrics endpoint. That is something you can see over here. That's a brief of, monitoring using just Prometheus for now. There's a lot to do next, but let's, take a pause here and cover this in an offline video. Going to open chat now if anyone has any questions. How's the pace? Overall, 10% slow, 80%, 70% perfect, and then 22% fast. So not a lot of people slow, which is surprising, but that means great. That means offline video is going to be much more, well-paced, structured. Thank you for the feedback. 20% feels fast. I think 20 is a little too much. All right, guys, opening it up for questions, class or otherwise. Chat is open. And if you understood everything, don't have any questions, of course, feel free to drop off. The class, will pause here. All right, start from the top. What is the limit of the small file? There is no limit. Let's Google it. I don't think there's any limit. How big can slash metrics be in Prometheus? I'm doing a project where I'm wondering if it's good practice to let Prometheus server scrape all these metrics. If not, yeah, so basically a lot of them. While Prometheus can manage many metrics and services, it all depends on hardware, mostly CPU, disk speed, and network. So with many metrics, memory might become important. I would suggest having multiple Prometheus, each get Prometheus to scrape from different devices. So yeah, basically there is no limit. But if you have a beefy machine, it will work. If you have a small machine, it won't. Can you give me some production ready must have practices in Web3 like Shamir secrets, MPC, indexing blockchains? Depends on the use case. For example, the ones that you've mentioned, Shamir secrets, MPCs are required for private key management. If you want to create a website where people can come, log in with Google, log in with phone number, and then, have a friend that can verify, then there also Shamir secrets are used. There's this website that raised a lot of money, magic.link, I don't know, something like that. That lets you do, crypto wallets with just log in with Google. Another good use case came to my mind, then went away. That was related to, it was a good one. Indexing comes in mostly everywhere. If you're creating a wallet, if you're creating an exchange, if you're creating an application where you want to show transaction, if you're creating a block explorer, if you're creating a social media website, you have to index the blockchain. You have to store all your relevant data in your SQL database and not, keep hitting the RPC again and again. What all are big things that you build? I guess that's your question. What are the difficult things to build other than, simple things? Something came to my head, went away. I'll think for 10 more seconds and then I'll proceed. Yeah, sorry, went away. If it comes back, I'll reply. What if the server goes down? Can't we start from zero? Yes. Can't will still start from zero. You can export metrics before server goes down and re-import them. But the good thing is, you worry about the rate. You don't worry about total number of requests. Sure, the total number of requests will not go down to zero. For 1 second, you will see a very bad, spike on your metrics. There were minus million requests per second on this endpoint. But then, it will again start from zero. Since you only worry about the rate of requests and not the total number of requests, if it spikes down to zero, you'll see an anomaly in your graph and then, it starts again. Why do we have the Prometheus.yaml file? If you start Prometheus low, it is the configuration file for Prometheus. Prometheus, you can tweak a bunch of things. For example, you might have multiple targets. You might have this application deployed on backend 1.100xdev.com and backend 2.100xdev.com. And hence you need to make sure your application is, you need to tell this to Prometheus. Where do you scrape from? Or as I said, if you want to alert in Prometheus, you might have to send an alert via email. How will it send an alert via email unless it has, some SMTP credentials? So, you might have to give an SMTP underscore creds, which has, username and some password, so on and so forth. So it's the configuration file for Prometheus. When Prometheus starts, it picks up the configurations from it. It's like your .env file where you put your secrets, right? This is the endpoint you have to, this is my secret for XYZ service. Similarly, this is the scrape interval, how often it needs to, scrape. You might ask, why not do in the UI? I'm sure there's a place in the UI where you can tweak this as well, maybe, I don't know. But yeah, this is where you just define all of your configuration. What if the server goes, okay, answer that. Hi, recently I landed my first freelance gig and the requirements are similar to Abraham. So I'm planning to do it with Spring Boot and React. Makes sense. My client raised a question how much the website costs on a monthly to be deployed live. Depends on the number of users is the simplest answer. For our server, it runs 20 different things. Still, it's like $300 a month, something like that. It's over provisioned. We don't need that big a machine. I just want to know average monthly cost. So 100 steps, as I said, yeah. Only $300 bandwidth cost is nil, very minimal users also. It's just over provisioned because when I was on a $100 machine, it would just go down from time to time for some reason during a spike. So on a $300 machine, it takes like 3-4% of CPU even on peaks right now. So yeah. Also with Lambda would make 150 users, 200 users, Lambda's fine. Cloudflare, fine. Very simple, cheap. Almost zero cost. It only becomes a cost problem at scale. Also, when your traffic increases, what should I do? Then it should be EC2. Else your costs will be really high. Lambdas are really slow, cold boot problem, all that jazz. So you would want to move to EC2 or VMs eventually. Initially it's fine to just go with Tabi Cloudflare is good because Cloudflare mein, if you write it using Hono, it's very easy for you to flip from Cloudflare workers to a simple EC2 machine. What if the okay, answer that. Is there any easy way to complete the Webflow website in Next.js? Convert. Oh no, not that I know of. Don't know of any library that you can take screenshots. Webflow lets you export things, I would assume. I think so. Yeah, it lets you export websites. So if you have access to that template, maybe buy that template and then you export the website. It'll export it in HTML and then you create your components from there. So you can do that. But the server goes down. I'll answer that. Is there a better way to find time difference? Yeah. Rather than using date.now? Not really. I mean, there are various variations to get the current time and the future time. But yeah, what's a better way to find the time difference between a request? You can do, I mean, so the thing is, one thing that we're missing is, that we're not doing great, is that we start the timer when the request comes here, when it reaches this guy. But it might have gone through a bunch of middlewares before. The request was in a buffer somewhere and then eventually reached here. So you can make this time more realistic. This isn't the best estimate of a time because it starts when the control reaches here and then finishes when finish. So still I would assume that this you cannot over optimize or optimize further, but the start time you might be able to get a little bit more before the control even reaches here. How do you do that is I will have to also find how can you capture a request came. Maybe there is some event that Express gives you where you can capture bhai request aa gayi, request has come. So over there itself you start the timer. That's the only other optimization I can think of. What if the answer that. And what if the endpoint accepts ID, dynamic URL? Will that count increase for that specific ID? That depends. How have you written your endpoint? So what have we written here? We have written, when we wrote it a while back, we were observing on route. If the route is dynamic, then every dynamic route will have a separate entering metric. So you should parse this. Okay, if rec.route starts with courses, then only have the route to be /courses/ bus, that's it, or :ID, something like this. You don't want the actual ID here, else if a million people send requests at /courses/ XYZ, you will have a million rows in your thing. That will be bad. All right, I lost chat, it went to the right. Notion, and then Docker Compose Up is not working. What error are you seeing? Can you put it in a Notion doc? Ask a TA. We have a lot of them now. They're pretty free as well. So ask a TA. They'll help you out. Sure. There's a simple thing. PhonePe has 0% UPI integration fees for initial 4 months and then around 1% cents. So can integrate before Web3 code and join, save 2%. Oh, I didn't know that. Thank you. It's also development effort. You see a phone call researching payment PR on CMS. Oh, got it. Who is this? To horizontally and vertically center a div, one can use this. Oh, nice. To create boil flex, just okay, let me just share my screen so people can see as well. This looks like an interesting thing. So who is this? MVP. Oh wow. Actually, this is you, sir. What are you? Do you know Python? And let me open chat. Do you know Python? Oh god, my chat is messed up. I'm opening chat for you, sir. Do you know Python a little bit? MVP person with the Vishnu. Was that Vishnu? Probably is Vishnu, right? No, Mahesh. Mahesh, do you know Python a little bit? Chat is open. Oh, you know him? Okay, chalo, we'll get in touch. Cool. What I was saying was, to create a boilerplate code for React, use RoughK. Sounds good. Slow internet speed. Sounds good. To create React frontend, and do it. Get a dot at the end. That's nice. To create, we should just put this somewhere on as an extras on the website. To create a file after folder, or you can just do this. That makes sense. Need guide. Oh, okay. 2 degrees. None of them is in CS. Background I am BSc in LLB. Oh wow, fucking hey, dude, your PRs are good compared to it being this. I started cohort in Feb and learned everything development cohort. That is Sounds wrong if you were able to do this. I don't know, maybe I haven't seen your PPR. Let's see. Let's see the code that you write. Okie dokie, that is good. That is good. Okie dokie, payment info, this is good. Looks pretty good. Let's see. What's your question again? Currently, I'm currently traveling 2 hours to go to court. I've taken a month off, bro. This would be quite a story, man. If you get in, so there's this company that just ask. I mean, I don't know your comp expectations, but it seems like it should be fine. Referral of any amount would be help me sustain. Beautiful. That's what I'm looking for. So there's this. Yeah, just get in touch with Akash. I guess we can go from there. No promises either way. In the meantime, check pending PRs is full time, as it's my full time earning a job. Sounds good. I will definitely put a bounty on this one, like a decent one. Let me review the code before doing that. But let me just start this. So let me review all of these first, and then go from there. And yeah, let's see what we can do, man. School, and no promises either way. But we were looking for someone. If you knew Python, but it seems like if you start learning this 2 months ago, you'll be fine. I don't think your background should matter, if I'm being honest. If I know the company well based on the code that you've written, but we'll see. Let's open chat one more time. Get in touch with Akash. We'll go from there. All right, a few more. Okay, let's pause it. Notion doc. Come on, where is it? Oh, there you go. 1. Notion doc 2. Everything is working fine in the code. How does Prometheus continue its count if we stop and restart? It starts from 0, unfortunately. But as I said, you can also export it. You can export the metrics and re-import them when the server starts. But it doesn't matter because the slope is what you worry about. If it starts from 0, you will see a spike. There were minus million requests a second. Then it'll, come back again. So since you worry about the slope, even if it goes down to 0, which it does, it's fine. Everything is working fine, offers an answer, but still getting HTML on the side. But for some reason, I'm unable to see remote video. Have you gone to about WebRTC internals? Did you see incoming bandwidth, incoming video? And if that is the case, if you do see that, then you should be fine. You just need to play it. You have some DOM issues which happen from time to time. Just call video element dot play again. Just give them a button, add controls to the video element so user can play, and it'll work. If you don't see that, then there's a problem. But open WebRTC stats, open about WebRTC internals, go over there and look at the connection state. Do you have incoming audio, video or not? Look at that. How can we monitor a single user, like what Google Meta must be doing? Oh, Prometheus is probably not the best way to do that. If you have 1 million users, you don't want user wide metrics. Prometheus is not the way to go. You probably need another service. Now, is there an open source, or probably there is? Let's see. User based analytics in Prometheus. Let me share my screen as well. I'm sure someone has figured out something. Let's see. Prometheus is a system with set alarms for spikes. There you go. So that was first. Scalability, stuff like this. The federation. Linio has real numbers, benchmarks about reads and writes, is feasible, not delete historical data, hot backup, with a sort of cardinality. Do you understand cardinality? Number of dimensions. When you probably get it working, this is unlikely the best option. You'd probably best off doing a log based approach such as EKL stack or something like this. That makes a lot of sense. Log, we'll be doing logging later as well, but like log whatever stats you need with the user ID, and then you can search based on them later on. Prometheus is probably not the way to go if you want to do user based metrics. That's a great question. All right, stop share. let me start from the bottom here. How does Prometheus, okay, answer that. When starting Prometheus in AWS, we would need to provide time series DB before starting. No, Prometheus is the time series DB. You don't have to start anything else. You just have to start Prometheus. It already has, it is already storing your data in a time series format. How many projects are left in the upcoming weeks? We have Kubernetes is the big thing to cover. Monitoring is done. Let me look at the syllabus and come back. But I think everything is done. At least there might be some minor things here and there. But Kubernetes is left, and then projects. That's Zerodha and the other one, Zapier. So yeah, maybe we do lead code instead of one of them. I don't know, because Kubernetes, prime use case, and also we need to do it anyways. So Sudhir is doing it. We'll do a poll. Hi Kirat, I'm looking for a job at very low salary. Is it okay to continue, or should I focus on learnings? It's fine. I'm doing a job for experience at very low salary. Depends on very low, but if you're learning, then it's cool. But if it's really low and it doesn't matter to you, then leave. But a lot of times when you leave, you don't actually spend that time learning or working. So make sure you spend that time learning and working. You're fine. Can and how we monitor? Okay, answer that. Logging we'll have to do Loki. We will do that probably in the offline video only, or next week we'll do Loki, which is a good way to do logging in Node.js or other libraries. All right. 2023 graduate, have done freelancing. Have given some interviews. Recently you got a job. Can you help me the referral? Connect with a mentor. Akash is your guy, sir. And PRs are always appreciated. Are the best way for us to look at as well. For example, the one that we saw right now, the person had really good PRs, and that's sort of what we looked for. What is this? Kubernetes commands. Display all the nodes. Okie dokie. Are these like notes for Kubernetes? Oh, is there a question here? There's no question, just notes. Pretty cool. Deployment, that sounds good. Is this using Notion? How are you doing color changes? I guess I can just do that. I don't do that. I should do that. But yeah, this is pretty cool. Looks cleaner than my slides for some reason. But yeah. Sagar. That's your name? Sagar? Cool, man. If you have any question, or do you want to show the slide, if you want to contribute to slides or something else, let me know in chat. Vishal has a very long file with no question. Oh, this is your WebRTC thingy that's failing. Yeah, try the thing that I tried. Very hard for me to look at this and tell until I look at slides. I won't be able to tell. Sorry, stats. Until I look at the stats, I won't be able to tell. Look at the stats. Still doesn't happen. Flag me only. I don't think any TA will be able to help you out on this. So yeah, let me know. But again, look at WebRTC stats. If there itself, if you open about WebRTC internals, you see that the peer connections are not connected, then so there's a problem before only. But most probably my guess is peer connection, because you're using React. React mein video can be problematic. So I think if you open stats, look at search for inbound dash video slash outbound dash video. And here you'll see incoming, outgoing audio video. If you do see some bitrate there, that means everything is fine. You just need to play it. It's a front end issue. Else it's a backend issue. All right, this. Building the suite, Web3 SaaS. You should also get in touch with Akash, but I don't know if you know Python. But basically, that's the guy I asked yesterday, and he said they have one opening now. So you should also get in touch with Akash. But yeah, too much offline videos are piling up. Yeah, I know, right? Any Web3 pumps? No idea. Which would be cheaper option for single machine, Prometheus, Grafana, or Neuralink? Which would be a cheaper option for single machine? Oh, depends on the number of analytics you have. If you have a billion records, then of course self-hosting would be better. But if you have very little, then Neuralink is free initially. So depends on what scale you're at. That's true for all services. If you use serverless, it will be cheap initially, expensive later on. Same for others. When will you go Kubernetes? What is the standard way for things to deploy in companies? Is it Kubernetes? No. Kubernetes is a little bit of an over engineering. If you either have a use case where you need it, where you need to bring things up and down really fast, or yeah, you just want to go fancy, you use Kubernetes. You don't usually need to for a long time. Things just work on bare metal /VMs / auto scaling groups. Yeah, it's basically just last thing. Companies want to get fancy, they go to Kubernetes, or there is a real use case where you really need to, or you want to go multi-cloud. Easiest way to do that is using Kubernetes. How does open source companies earn when everyone can self-host? People don't self-host. People understand that these guys have the expertise, and they let them host. They host through them. Also, a lot of times companies host, like, open source some part and don't open source the real mode. They say bana lo, isko banana hai. If you want to build it, this part we will not open source. For example, LiveKit is completely open source, but distributed WebRTC based SFUs is one part they haven't open sourced. So depends. That's like one of many ways, and a lot of times companies don't care. So open source doesn't mean you can't make money on top of it. The problem happens when it is open source and Amazon makes money on top of it. Most people use Amazon. A new service came, let's say Prometheus. Amazon released one-click Prometheus deploy, and then everyone's deploying. Amazon is making money based on an open source tool. That's when it becomes a little problematic. Will these companies then sponsor? Yeah. Are you? Okay, answer that. Building this week Web3 SaaS, nice. Pending things, work front end, nice. Perfect. Thanks for sharing Web3 content already. Great. Cool. PRs, let me start this as well. So you two guys will be the first ones that I look at. With that, I think it's any other Notion doc? No, don't see it. Cool, guys. This was it for today. I will see you guys next week and with some offline videos. Someone said they're piling up, so seems like I have to put in a few. With that, let's end it, guys. I will see you guys next week. Have a good night and stay safe. Have dinner. Oh, someone said I'm a Python developer. If you are, get in touch with just Akash. Just ping Akash. Go from there. He's in Discord. He's one of the mods. All right. Any alphas for today? Not much. Nothing really. But yeah, I have nothing. Delhi meetup. Figuring things out there. Bye, guys. Have a good night.